Good morning students. I am your Nagini ma'am. Today I am going to discuss about the coordination number, how to find in FCC structure. Okay, in the previous classes I discussed you coordination number in a simple cubic structure, in a BCC structure I discussed. Okay, now I am going to discuss about the FCC structure students. So first of all I am taking the cubic unit cell. Okay, cubic unit cell, these values already I gave you students already. How came this all values, everything I discussed in the last class. Okay, so this value, direct values I'm writing students: 1 by 8, 1 by 4, 1 by 2, this is 1 here, 1 by 4, this is 1 by 2, and this one is 1 by 4, this value is 1 by 2. Now this phase center value 1 by 2, this phase center value 1 by 2, this phase center value 1, and this phase center value 1. This is the body centered particle, contribution is 1. Clear? This all values in the last class I discussed with students how came this all values. Okay, now I'm taking the body cubic unit cell students. See here, cubic unit cell. Okay, so here this is the considered particle, this is the considered particle. It is in touch with this corner particle, and it is in touch with this one and this one, correct? These three particles, corner particles. Okay, and next this is FCC kada. FCC means face centered, face centered particle. So that means we have to take up to the one face centered particle I am taking, and next one is body diagonal particle I am taking. So this is the body diagonal particle. Clear? So here which is the first nearest? This is face centered particle, this is corner particle, and this one is body diagonal particle. In these three particles, which is the nearest to the considered corner particle we have to find. So first I am going to calculate the nearest neighboring distance. So first I am taking corners. So okay, see here, corners. Next, body body diagonal particles, body diagonal particles, and another one is this is face center kada, this face center particle, face center particle. Clear? So three particles I am taking. One is corner particle, another one is body diagonal particle, this is the face center particle. Clear? So these values already we know, already in the last classes I discussed with students. From here to here edge length is a kada. So this distance is how much students? A. And body diagonal particle, this particle from corner to this corner, this distance is body diagonal length is √3 into A kada. So that value I am taking. And face center, actually face diagonal value how much? √2a kada. So √2a half value have to take. So that means √2 into a by 2. So till center only we are taking kada. So the length, the distance from corner to center, face center. So that's why we will get √2a by 2 you are taking. So then you will get this is 1a, this is 1.7a, this value is 1.4a by 2. Then you will get 0.7a, correct? 0.7a. Now which is the smallest value students? This kada. So that's why it is the first nearest. Clear? So that means face center particle is very nearest to the, very closer to the considered corner particle. And body next second nearest, which is the second nearest corner particle. So this is the second nearest. Clear? And third nearest is this one. So third nearest is body diagonal particles. Clear this one? So first nearest is face centered particle, second nearest corner particle, third nearest is body centered particles. Clear this students? Now I am going to calculate the coordination number for first nearest. Okay, so first coordination number for first nearest. So for this one I am taking one cubic unit cell. See students, this one. So first nearest are students, first nearest is face center particle. So that means this is the considered particle, this is the considered particle students, this is the considered particle. Now to this considered particle, first nearest is face centered particles. So to this face, one face center, this particle, and to this face, here one face center particle is in touch, this particle, and next to this face, Nana, you are taking one more face center particle. Clear? This is this phase center, and this phase center is this one, and this phase center is this one. That means three phase center particles are in touch with this corner considered particle, students. Okay now, so that's why this particle contributions, how much, students? This phase center particle contribution is how much? 1 by 2, 1 by 2, 1 by 2 kada phase center. So these values I am taking as 1 by 2. Their contributions just I am writing 1 by 2. Okay, now how to find the coordination number? So coordination number is equal to the total 8 corner particles, and it is in touch with 3 phase center particles, and phase center contribution is 1 by 2, students. So 4 3s are 12. Okay, and next, second nearest I am going to calculate, students, coordination number for, okay, second nearest. So how to find it? Second nearest, how to find? Again, take here simple cubic unit cell, students, simple cubic unit cell, and this is the considered particle. This is the considered particle. Second nearest which particle, students? Corners. So it is in touch with this corner and this corner. Okay na, and next one more corner here. Okay, so total 3 corners. So then how to find coordination number, students? Coordination number is equal to total 8 corners, so, and each corner particle is in touch with 3 corner particles, students. 3 into each corner contribution is how much, students? This one, this particle, this one. So this, and this particle kada, this one. How much, students? Values, contributions, their contributions 1 by 4 kada. So that values you take, students. So here 1 by 4. Then 4 2s are 8, 2 3s are 6. Coordination number for second nearest is 6. Now I am going to discuss the coordination number for third nearest. Okay, coordination number for third nearest. See, students, again I am taking the simple cubic unit cell. Okay, this is the considered particle. Third nearest is body diagonal particle. So in cubic unit cell, only one body diagonal particle is possible, students. So only one particle will be there. So coordination number is equal total 8 corners, and it is in touch with one body diagonal particle, and this particle contribution is how much, students? Body diagonal particle contribution is 1 kada. So the value you have to take 1. 8 ones are 8. Clear? This is the third nearest, students. Clear this, students? So first we have to find the nearest neighboring distance. This is the nearest neighboring distance. So which is the nearest one we have to find? First nearest is phase center particles. So that to the considered particles, phase center particles are very nearest phase center particles. Second nearest is 1a. This is third a. That means based on the value, students, based on the distance we can understand which is the first nearest, second nearest, which is the third nearest. So this value is very small kada, very smallest value. So that's why it is the first nearest particle. That means phase center particle is very nearest to the considered corner particle. And next, second nearest is body diagonal particle. So corner particles are second nearest. Third nearest is 1.7a. Clear this one? This is the coordination number first nearest, students. This is the first one, and coordination number for second nearest, this is the third one, students. Second, third. Clear this, students? Okay, thank you, students. I hope you like this video. Please, if you like this video, please like, share, comment and subscribe my channel, students. Thank you.